We're going to take a minute reviewing Modulus. Modulus is something that may not show up on the exam, but it's one of those things that every once in a while it really, really, really simplifies things if you're comfortable with it. So I want to just make sure that it's a tool that's in your tool belt, even if it's something that may show up, I don't know, once every 4 to 5 exams. So just a reminder, modulus is like the remainder after you divide something. Also, you need to be comfortable with integer division. Again, integer division does regular division and then just leaves off whatever the decimal remainder is. Okay? So here's an example. We're going to be doing modulus 12 and division by 12 for the numbers 0 through 24. So let's see what happens when we do this. So what I want you to see is this is kind of like the way time works, where you've got, again, 0, imagine it's like 12 o'clock, okay? And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you're back to 0. You're back to the beginning. So modulus works really well with anything that cycles, okay? Integer division is good when you want to know how many times a full thing has happened. And then you can deal with kind of the leftovers later, which modulus shows how many is left over. So they work really well as a team because the integer division tells you how many full times it's happened, and then the modulus tells you how many leftovers there are. So again, they work really well together. So I wanted to show you a couple of applications here. That is not it. There we go. Okay, so the first method I'm going to show you is duck, duck, goose. Now, duck, duck, goose just prints duck, duck, goose, duck, duck, goose, duck, duck, goose, and it will print as many words as you tell it to do, and it'll do it in that pattern. Now, you could write something like this, and you'd have to write something like this where you can break in the middle because you don't know how many times the pattern's going to go, and you may have to stop in the middle. But I recommend coding something more like this. See how much cleaner this is here? So you just do a for loop, and then you say, hey, if it's the third time, which, remember, 0 would be the first one in the pattern, 1 would be the second one in the pattern, 2 would be the third one when you do this modulus 3. Okay? So if it's the third one, print goose. If it's not the third one, print duck. We could also have a different value for each of these if we wanted to. But what I've done is I've said, hey, let's do this 17 times. So what it does is when modulus is 0, it prints duck. When modulus 3 is 1, it prints duck. But when modulus 3 is 2, it's going to do goose. There's a lot of problems they'll do sometimes where every other one is different rather than every third one. And so then you just do modulus 2, 0 would be the first time, 1 would be the next time, 0, then 1, 0, then 1. And that way you don't have to worry about if it ends on an even or if it ends on an odd. You don't have to stress about that. You can just say, hey, if it's this, we do this. If it's this, we do this. And just do that pattern forever. Okay. So it's good whenever you have something that happens in a repeating pattern. There's also an application that we haven't talked about a lot. And what that is finding the value of a digit of a number. Like if you have the number 123, you'd want to be able to look at just that 3. And there's not really a great way of doing that, typically. But what we can do is we can do modulus 10. Now, modulus 10, it's like if we were dividing by 10, what would be left over? And what would be left over would be that last digit. Okay? So here's an example of looping through an entire number one digit at a time. So first of all, the way you're going to want to do that is with a while loop. And we say we're going to do that as long as the number is greater than 0. So we take the number, do modulus 10, and that's going to grab that digit. In this case, I'm also checking to see if it's even. Okay, mod 2 equals 0. That's the main use of modulus, is divisibility, but I figured y'all would remember that. Here I'm adding the even digits, so if it's even, I'm adding it. But look at what I do at the end. I say, okay, now we're going to divide the number by 10. And what that does is it just chops off that last digit. Because remember, any decimal is gone when you do integer division. Okay? So what we're left with is we chop the number off and then we go again. We use modulus to look at the last digit and then divide by 10 to get rid of the last digit. And we do that again. Look at the last digit, then chop it off. Look at the last digit, chop it off. And when we get down to 0, that means there's nothing left, so we stop worrying about it. Okay. Now there's other ways to do this. We could use the character.getNumericalValue thing if we turn it into a string. It's kind of a gross thing, especially if you don't have this in your back pocket. But again, divide by 10, chops off the digit, modulus 10 gets that last digit for use. So you might take a look at that, maybe try your own method using that. Okay, let's just test out our method real quick. Add even digits, it should add the 8, the 2, and the 6. And it did. Okay. So the last one I'm going to go through is how you cycle through something. In this case, I want to cycle through an array. Okay. Like, for example, let's say I want to start at lizard, and then I want to go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I want to go kind of start over, start over. Okay, any sort of cycle. That's a huge hint that you're dealing with something that you want to use modulus for. So let's see what I did. So what I did a regular for loop. We loaded in the array, where we're starting, and how many times we want it to run. So what I did, I said, hey, we want to start at my start position plus A. Now, that seems really good for the first few until you realize, oh no, I'm going to go to the end of that array instead of looping around. Well, how do we loop around? We do modulus whatever the length of the array, however many things there are that I'm cycling through. Okay? And what that's going to do is whenever I hit where it would normally be out of bounds, if I divide that, it winds up with a remainder of 0. And then 1 and 2 and 3 and then however long, and then it loops back around. So I basically say, hey, I want the value of the array at start position plus A modulus array.length. So it's gonna go where it's supposed to, add however much it's supposed to, and if it needs to loop around, it'll do that. Let's take a look at this method in action. So again, it's forming that pattern. So anytime you see a cycle or an even odd, and you're thinking, oh, that seems nasty, consider using modulus. Make sure you're comfortable with it. All right.